Hello guys, welcome to episode number 11 of Tech Detonator Show. So today's episode and guests really are special to me because they are both really special. This is the first time we are collaborating with National Research Council of Canada, and that's why we have Jasper Arthur from NRC, from Robotics Manufacturing in Winnipeg facility. So we are going to shed some more light on what robotics manufacturing is in detail, and also reflect upon the current topics of AI, machine learning, machine vision, and robotics assistance. All right. So I hope you guys enjoyed the episode. Take care. All right. So first of all, thank you, Jasper, for doing this. So currently, I am with Jasper Arthur. He is a researcher in robotics manufacturing at National Research Council Canada. So thank you so much for giving your time. So let's first dive into your what your role is here, how you have reached here, what was your study base, and how you got this position and what you do actually.
Sure. So I'm Jasper Arthur, research officer here with the NRC. I started in mechanical engineering. So my background is at the University of Manitoba. That's where I got my undergrad. And then I continued on to do my master's at the U of M as well. And that was in robotics, digital manufacturing, how to make things with robots better. And that was with the Intelligent Digital Manufacturing Lab and Matt Kostregi as my advisor. And right out of school, I was fortunate enough to get a position here. They were looking to expand the team. This is a relatively new facility, and they were just starting to hire for full-time employees.
Awesome. So currently, we were just discussing about what of the research you are doing right now. So let's first get into how NRC is doing collaborative programs. So can you shed some light upon how the collaborative programs are done at NRC, and how can people approach it and make a use of it?
Sure. So the NRC exists to support Canadian industry. We help you do research. We're a collection of scientists and technicians and supporting staff that are really just doing research projects. So we're not a funding agency. Some people get that confused, but basically you get in contact with us either through email, through chatting, meeting in any other environment, and talk about your research needs, right? We go and visit a lot of local industry to see what their pain points are. What are you having troubles with? What's a problem that maybe the commercial solution only does like 80% of what you need it to do, and you need to dedicate some time to research to really fix that last 20%. We can help with that. We have scientists all across the country specializing in different areas, and so if there's a problem that I hear about from a colleague in Montreal, there's a company that's has a problem with my area of expertise that they're not familiar with, then they put us in contact and we develop some kind of research project together. And then that can also bring in professors from university who will contribute the time of like grad students to work on these projects. It can also be just a straight, you pay us for some research time and some equipment usage, and we do work together. But it can also be broader. We have industrial R&D groups, which are a means for a lot of different companies who are all interested in kind of the same thing to come together to do some pre-competitive research. So you and your near neighbors in the supply chain might all be interested in, I'll take metal tech as an example. They do it's for aluminum research, aluminum manufacturing research, which is a huge industry in Quebec. So there are a bunch of different players who are all interested in aluminum manufacturing, and they band together. They all pitch in a little bit of money and give it to us for our time, for equipment to do the research, and then they all get the results. So it's a way to really leverage your investment a lot more than if you had to pay individually for for all that research, but we're kind of a neutral third party that is able to bring people together around the table that might not otherwise join together.
Awesome. That's one of the great insights, I would say. So while you're doing research, and can you also tell how does NRC foster the environment that will encourage innovation among you? So you're a research officer, let's say, and how do you get motivated to do research, and how do your seniors motivate you, and how do you motivate your juniors to foster that environment and culture of innovation?
Yeah, I think that's really important, is to try and get a lot of that cross-pollination of ideas, where you have experts in a domain. A lot of what they do research on is not necessarily tied to that specific application. If they're able to get a bit of exposure to a completely different field of research, there might still be some overlap that the ideas could still be useful. And I think the NRC does a good job of that. For example, I have a lot of opportunities if I'm going to a conference somewhere else, conference in Ottawa, or like a project update somewhere in Montreal. I'm able to also go to other facilities. So I visited research centers that are completely different from my own, and been able to meet with the researchers there, talk to them about their projects, and share my ideas. And so that's led to me being involved in projects with other research centers. And that's one way where if you're just self-contained within like one place, one company, it can be difficult to get those ideas, apart from just trying to read papers from other people and pull that in. I think the NRC does a good job of that. And we also have a lot of different people within one location. So this advanced manufacturing research facility, we're home to, like, as I showed you, 3D printing processes and robotics and automation. But we also have sustainable food packaging, which at first glance doesn't really fit into the like automotive side of the name of our research center, but it's a good way for us to serve local industry. There are a lot of people who are interested in that food packaging research here in Winnipeg, and the researchers that work on that have ideas that are really useful to me. So, someone with a polymer engineering background, I might, at first glance, doesn't seem like someone who I might work with for 3D printing, or in robotics, but then I have a 3D printing with a robotics project, and they're an expert on finding the melting point of polymers and helping me figure out the process parameters. So there's really a lot of opportunity for that when you have, a large organization that has reach across the country to a lot of different experts, as well as multiple areas of expertise all housed in the same location. Yeah,
that's a great one. So let's look at it from a different way.
Sure.
Let's generalize it for any institution. So if the person is expert in their own field, but so he has done relatively good work in their own field, but when he is asked to give a perspective on a relatively new field, which could relate to their field at some level, but they would be looking at from as a fresh new glass perspective, and that might give them they would give a better idea sometimes, because the people who are working on that field are already used to the ideas and traditional ways, and they might not be able to expand their mindset with the new person who is looking at the new field.
Exactly, right. I think if you're putting together a team for any company to do research, and your topic is very specific, if you only hire people with that specific background or the right buzzword bingo in their resume, then you're going to kind of pigeonhole yourself into that way of thinking. But if you bring on, if you imagine, okay, I can't hire anyone, but who are the best people that a corner of their job might overlap with my research project, and you bring a few of those people together, and maybe you still hire someone who's can lead the way and has the most familiarity, but you get all those outside perspectives. I think that's really valuable, and I think that's that's an approach that in my projects, at least, I try to emulate, where we're getting perspectives from other people and pulling in people from across the country who they don't specifically work in that area, but they might have some insights and some ideas.
Yes, nice way to look at that. So as compared to the institution who are just at one location based, would have a less innovation culture as compared to the multi-institutional practice, or the people who are allowing to do cross-pollination between many events happening?
I think that's a risk, but it could also be that could be to their advantage, because a very local company will typically have better roots. You'll be more connected with what people need right now, right here, and you might even, I don't want to say forced into working with what you have, but you do the most with what you can, and so maybe you don't have the option to hire 6 new people in that very specific area, and it just becomes a side of desk project for a few people who are already at your organization. That I don't think there's necessarily one right way, but for the NRC, we fulfill that national level, broad organization with a lot of different specialties that hopefully small and medium enterprises can tap into. So you have the advantage of being on the ground, knowing what the people need, knowing what your product, what issues you're having with building your product, and then you can also leverage the diverse range of expertises from the NRC researchers to get the best of both worlds. That's the idea.
Awesome. So let's go towards the strategic plans that NRC has right now. So given the broad spectrum of research topics that are covered by NRC programs currently, let's say there was digital instruments to robotics in healthcare and manufacturing. How does NRC prioritize the research initiatives at your, if you were to look at it, you are a research officer, what would be the best tips and practices for the others to follow if they were to get the best shot at partnering up their research with NRC?
Yeah, in terms of how NRC makes its high-level strategic decisions, that's up to the president, it's up to the high-level program leaders, but that gives us guidance on sort of the direction for research. As a researcher, I have a lot of individual freedom on the types of projects that I choose to work on. Obviously, I have my background, I have the equipment that's available to me, and my research has to be relevant to industry. But within that, we're given a lot of wiggle room to try and figure out what the best path forward is. Yeah, provided it aligns, of course, with those program directives. So if you're, I think regardless of any project that you might have as a company, don't immediately disqualify it because it doesn't appear on the NRC strategic plan. There are so many little programs within all those high-level goals, and they are pretty broad high-level goals. So you can still come talk to us and figure out if, together we'll figure out if the project is suitable for our expertise, as well as our facilities, our equipment, and our strategic vision overall. But I would say that in general, we are a very wide and diverse organization that's able to find something, or able to find a relevant program or someone who's interested. Because we try and do our due diligence to make sure we're up to date with Canadian industry. We know what the needs are. But if more and more people come asking to us to do research on this new domain that didn't exist 3 years ago when the old strategic plan was made. We just launched a new one, but say, for example, 3 years from now, there's a new technology that comes forward. We have to adapt. We have to we have to listen, and I think we do a good job of that.
Okay, awesome. So while you are doing your research programs, if you are integrating this strategic priorities with your existing plans, from let's say your new plan is just released for next 5-year strategic plan. In between, as you said, you are very good at adapting new technologies, but is it common to take influence or let's say inspiration and lessons from other countries' developments?
I think it's necessary in research to look at the global field. It's always going to be a balancing act of trying to emulate what someone else is doing versus being confident in your own direction and going off in a way that you might not see other countries doing. We do have a number of high-level strategic partnerships with a few partner countries where we have closer ties with them, and we want to do research in specific domains that are aligned with both countries. And so we get researchers from the UK, for example, and researchers from Canada to collaborate on projects. But yeah, we want to make sure that we are relevant to Canada. And so Canadian industry is by far the biggest voice that we are listening to, without completely putting our fingers in the ear and ignoring what's going on in the rest of the world. But we are leaders in a number of like scientific areas that you how do I say, like you don't necessarily want to follow the herd. If you know that you have good research and that you're doing good work and advancing the field, then it's okay to break off on your own and
makes sense.
Keep moving forward.
Yeah, that's how you get. I think that's the best way to get ahead of many other countries and stay on the top of it since many years. Because I was just reading up on NRC, and it says that our research in AI, robotics, and machine learning, we are the global leaders in those areas. So do you recently, do you often come across those type of events where AI, robotics, and machine learning are being talked upon, and how much that industry is growing within NRC after post the ChatGPT bubble?
Right. No, it absolutely has. Like everywhere else, it's exploded out into the scene, and yeah, Canada absolutely is a leader in AI, machine learning, in quantum technologies. The advent of readily accessible generative AI or large language models has been it's something that we're not I guess a lot of researchers weren't surprised by. Like they were already doing research in those fields. It just wasn't as visible to the public and easily accessible as ChatGPT, for example. But as a lay researcher who just wasn't in that field specifically, like I'm robotics is my specialty. AI didn't cross into that a whole lot. So when that became available, it was very interesting. And I think the NRC was pretty quick to acknowledge that and to start putting it to use for us. So we have a team within the NRC who's working on developing our own internal, for internal use AI tools. Who's we got a lot of instruction on how, not just AI bad, don't use AI, which a lot of companies, that was their default stance, and I think is prudent when you don't know the risks of something. We had measures in place. Okay, here's what you can and can't put on these platforms. Here's what you can and can't use it for. Here are some pitfalls. Here's our researchers really probing it and trying to figure out where it's good and where it's bad, and then informing the rest of us of the results so that we can use it in the most responsible way.
Obviously, because most of the strengths of these AI, let's say, for example, the biggest one is the OpenAI. That's what we are using ChatGPT nowadays. The biggest strength of that is collecting data. And I think going forward, data is the biggest strength that is going to be useful. How much people you are consuming data from.
Absolutely.
Gives you control.
Absolutely. Data is king. Everyone wants data, and this facility was actually built with that in mind. So we are collecting data on everything that we're doing within the facility. So when we run 3D prints, we are collecting the data of what parts did I build, where were they in the build plate, what are all the different process parameters, and that gets stored in our database so that even if we're not fully leveraging it now, we're collecting that data for the future so we can inform
the future
physics-based or future AI models to help train them. We were looking at one aspect of machine learning that is quite popular for robotics is machine vision. So figuring out, being able to identify what's in front of you from your camera, that's very important for a robot to adapt its programming to what is needed. So it's absolutely an area where there's a lot of interest from my side personally and within the NRC. It's one of the big parts of the strategic plan is that looking at the digital environment and making sure that we are well positioned to take advantage of it.
Not much about that. Later we'll talk about the cobots that we just saw, right? So I think that's where you use the machine vision for the cobots to work along well with the humans, right? So we'll talk later about that. Before that, let's address this facility.
Sure.
So what are the core technologies that are being developed at this facility? What are your main goals at this facility, and how do you align with the strategic plans in this?
Sure. So this, we're in Winnipeg at Brookside, the Advanced Manufacturing Research Facility. So it's a relatively new building, just north of the airport. We were, open for people to be in here around 2021, started actually getting machines operational online, big ribbon cutting, all that fancy stuff in 2022, 23 kind of timeline. And so now we're just in the early stages of getting through the first research projects and getting those under our belt. And the facility it's in the name, Advanced Manufacturing. We're here to build things better. So we want to figure out how we can transform a manufacturing process into a better manufacturing process, whether that means quicker, more efficient, so less waste of material, more sustainable or automated. That's really the big push. So some of the technologies we have to support that, we have two metal additive 3D printers. So a binder jet based printer and a laser powder bed fusion printer, able to print up metal parts layer by layer and create geometry that you would never be able to make using subtractive manufacturing, like machining, milling. We also have facilities for biodegradation and assessing the sustainability of polymers. One of the pieces of equipment that we will be getting in the future is a film cast line, and that's for creating that plastic packaging. And so we'll be able to change the chemical formulation in that plastic packaging and then do the analysis. Is this better for the environment? Is it worse for the environment? Is better, more sustainable to source and produce? And if it is, does it still have the same properties as something that was made before? You hate holding the plastic bag and it just rips and all your groceries spill it on the floor. So It still has to be as strong as those the petroleum-based products, but still sustainable.
Right balance of the biodegradability and sustain.
Exactly. So, and just to finish off there, the other sort of large segment of equipment is in support of digital manufacturing, and that's in robotics and automation. So that's where I spend most of my time, and we have an industrial robot that's more of a large scale fit in a walled off enclosure. That's where you do more more manufacturing, proper manufacturing of you can imagine welding car parts together, or right now it's set up to do 3D printing. And we also have a cobot, and that's for assembly with working with a person, right? Taking advantage of the COBOT's abilities to be a robot, very repetitive, very precise, and also the human's ability to do those fine detail work and things that you might not be able to program a robot to do. So those are the main pillars, and that's, I think, very well in alignment with the overall NRC strategic plan that was just launched.
Okay, awesome. So we use the terms like subtractive manufacturing and additive manufacturing.
Yeah.
Would you want to give a little light?
Sure. Yeah. No, it's all good. Sorry. So basically, subtractive manufacturing means you start with a large, whatever size block of material, and then you remove material away to build your part. This is relatively easy, and that's what you do when you drill a hole, right? If you drill a hole in your wall, you started with a big sheet, and then you use the drill bit to remove some material. Additive manufacturing is going the other way around. You start with nothing, and then you add material on just where it needs to be, and that can usually help you save material. So if you, maybe hard to, I'll do my best to explain without relying on visuals, but if you have a cylinder and you need to you need to roll that cylinder, kind of like a rolling pin, but you want to add like a cookie outline on the side of it, so that when you roll it, it creates this little cookie cutout pattern. Well, if you want to make that using subtractive manufacturing, your stock material has to be as big as the biggest part, right? It's got to extend all the way out to the very limits of the edge of that cookie cutter.
Yeah.
But if you have additive manufacturing, you can start with a rod that is the size of your rolling pin, and then just add a little outline of material on the cookie cutter where it actually matters. So it's a new approach, and there's advantages to using both of them, to taking advantage of, like, that's what hybrid manufacturing is often like a combination of additive and subtractive, and you're taking advantage of both of them to build your part.
I think that's a saving time, efficiency, metal, because if you're cutting and in subtractive manufacturing in different shapes, then you have to melt them and make it reusable. You have to do a lot of stuff. Okay.
Exactly. It's a really it can be a very wasteful process, and that's why additive manufacturing is taken up more and more. But there are other advantages, like being able to make things that you would never, even if you wanted to make them using subtractive manufacturing, you never could. So the example I like to use is cooling channels. So if you have to drill out if you have to machine out cooling channels, you have a drill bit. And that drill bit is straight and it spins. So you can't go around corners, right? You can only kind of go in straight or 90-degree lines. But with additive manufacturing, you have so much more flexibility that, because you're building layer by layer, you have access to the cross-section of the part as it's being built. So you can create these vein-looking cooling channels that run through the part and interweave and follow the surface very closely, that you would never be able to manufacture using like a
subtractive manufacturing.
Exactly. Yeah.
Awesome. So let's look at looking in the future. Mm-hmm. What are the next big technologies that the facilities is looking at right now and focusing within the realm of advanced manufacturing?
So those are really I think we're well positioned for the future. We did a lot of consultation with the local stakeholders, the companies that are interested in these technologies, as well as, hey, what's available at the rest of the NRC, and making sure that we fill those gaps and are able to be relevant for a long time going forward. As I mentioned, we'll be getting a film cast line as kind of the next big acquisition. But we're really interested in leveraging all that we have and making it like really de-risking the adoption of this technology for Canadian industries. So when it comes to 3D printing with metal, right? If you want to 3D print with metal, but no one can tell you what the right process parameters are, well, we can help you figure it out. We can help you do all the experimentation so that when you buy the machine and want to put it into production, it's ready to go and you know how to use it. So a lot of what we have is designed to be long-term, adaptable, right? We have the 3D printers, well, you can keep changing the material and changing the strategies so that it's relevant for a long time. We have robots. You can put any tool on a robot. So long-term going forward, we can adapt to whatever project we need to.
Great, awesome. So that was about how you are also helping the Canadian industries looking forward into the future of manufacturing and helping them set up the parameters so they don't have to do the research, the common research, and waste their time and resources. And instead, you will provide them with everything, because if they're setting up a new plant, as we were discussing, it would be difficult for them to research and spend a time of over 6 months or a year figuring that out.
It's really difficult for a company to spend money on R&D. For some companies, spend money on R&D, and that's where we can help, right? So instead of having to buy all the equipment to hire full-time a researcher who's an expert in that domain and needing to like maybe halt the rest of the production line in order to do these experiments, we're kind of that central neutral third party that a lot of different companies can tap into to leverage more of their research dollars into functional, tangible results. That's what we're really interested in, and it's really a challenge for a lot of these small and medium enterprises, especially for robotics, where the barrier to entry can be very high. Like to set up and program a robot cell is something that you do need a bit of experience and expertise in that area, and so there aren't typically people on staff who you can just say, oh, you go build a robot cell now. It's not just an easy task. It's something that almost always gets outsourced to an external integrator who delivers a cell, and then it's done, and the company still doesn't have to hire a roboticist. They just need to have someone who feeds material in, presses the green button, and collects it out. But partnering with the NRC, you get access to a bunch of robotics experts who are able to help do the experiments, teach, and get a better and more robust foundation for understanding the deployment of robots. And that's not to poo-poo integrators. I think that it's very important, and especially for there are a lot of problems which it absolutely makes sense to just get a black box that is a robot inside, and you feed material in and something else comes out. But for a lot of what gets made here in Manitoba and in Canada, that sort of low volume and high mix of products, it really behooves the company and the people working with the robots to understand that more and be able to have that reprogramming ability of the robots, that flexibility and adaptability.
So very interesting question related to this. If the companies are bringing the idea to you, let's say their research project was approved, at the end, if it was done well, the patent, whom does it go to? If that was a new thing developed, whom does the patent go to?
That's an interesting question, and it's a case-by-case thing. Like, there's always going to be IP agreements written ahead of time for whatever project gets started. In general, the NRC is like basically, if we invent the IP, right, one of our researchers doing our work invents it, then we own it. If it's something that, if the company already had the idea and they say, like, we have this idea, we've already submitted a patent, and now we have the idea and we want to commercialize it, right? And they come to us. We don't steal that away. And then if it's some combination, right, some jointly created IP that arose during the project, then it's handled according to whatever joint IP clause is is written in the contract.
Okay.
But it is kind of a case by case thing, and we will do. So we do have, apart from partnering with companies, we also do some internal research where it's just, hey Jasper, I go try and develop something over in here. Here's some money for it. Hopefully it'll be useful, and if IP comes from that, then the NRC owns it, but could be licensed out to other companies. There are so many different models that the answer is really it depends. But yeah.
Oh, okay, understandable. So obviously, depending on how the rules or their clause and the laws are being followed, and who is inventing, to give their own credit. But so there is also a possibility of partner IP, where if both of them are inventing, and if there is, it depends on the clause, and it's like that, then it goes as a partner.
Yeah, and that's more the area of the contract people and the business development side. But there are different rules depending on who invents it and how much each party contributes to the
obviously, yeah, definitely there are rules for that. We will not go into the legality of it. So following that, you said you are doing also some internal research. So in robotic manufacturing, what you believe will be the most emerging trends in the upcoming decade?
I think for robotic manufacturing, one of the big ones is machine learning. That's really in the aspect, and specifically as applied to machine vision. So being able to see with a robot opens up so many possibilities that to me are really exciting, and I think would be very impactful for manufacturing, because robots as they stand right now, you program them and they will just keep doing their programming over and over and over again. If something changes in the environment, they don't know about it. How are they going to know about it? You have to kind of explicitly tell them, like some might have a distance sensor and right? So go until you touch the part. Okay, then now I know where the part is. But to be able to just see the entire environment and see, okay, I got a new part in front of me. How am I going to adapt my programming to it? Oh, I see there's a human. Let's make sure I don't go near them. Being able to incorporate that vision system onto robotics, I think, is going to be one of the big emerging trends.
Okay, but I'm a common man compared to you in this, so I'm just a little bit curious and doubtful. Isn't it already existing there out? Because we see in the car there are sensors, and good level of cars there is a sensor. Even in the night, it recognizes who are humans, human lives, and as well as the which are inanimate objects. Is it that already out? I mean, is it easy? How is it difficult for the robots? Can you explain what is the challenge right now? Because from my imagination, you guys or NRC advanced facilities like this, that's already in use since long before 5 years,
right?
Probably.
So I think a lot of the places you see machine vision are, like you gave good examples of, like for example in self-driving cars or connected and autonomous vehicle or semi-autonomous vehicles. They have a lot of cameras, but and those machine vision algorithms are always collecting data, always getting better, always learning. But where they have not been deployed as much is on manufacturing robots. So that's the robot arms that grab a part, move it somewhere, drill a hole, or do these processes to make something. When I go to the trade show, the demo that you always see is like a cobot with vision, and it's like, oh, I can put the parts anywhere, and it'll go and change its orientation and grab that part. And that's been a perennial demo that you keeps cropping up and everyone sees, and it's helpful, it's useful, but it's not. I don't think it's really seen as much adoption in that manufacturing automation as it could, as vehicles, for example, right? Someone had the idea for a rear view camera, and then, okay, now we got cameras on all four sides of the vehicles, and we're always looking at everything and collecting all that data. But for robots, still a lot of those systems do not have vision incorporated in them. And when you do add those cameras, the possibilities of what you can do with them, I think, are very exciting to be able to adapt and change. So you're not just recognizing that there is something going on. There is a human here, right? That's one challenge of machine learning, is recognizing what's in the frame. But then, how do you change your programming to account for that? I still want to move around, but now there's a human. How do I intelligently modify my trajectory? I still don't want to hit anything. I still have to keep the part in this orientation so that the glue doesn't spill or whatever. But so making use of all that vision data along with what the manufacturing robot is already trying to do, that's an area where I see a lot of growth potential.
So if I put it in simple terms, if a car is going, there is a human there. Right now it just stops. It's a forced feedback, possibly, right? That if it recognizes human, it just stops. But what we are looking forward is how it defines its own trajectory and goes forward. When it moves forward and doesn't stop moving.
Right. You can imagine those crazy busy streets in China or India, or people walking. How does the car navigate through those and find a safe path? I don't know if they do that yet, but that's kind of an aspect of what we want to do with manufacturing.
I think right now they just stop and they move. They wait for the entire pathway to be clear again to get moving, but not figuring out the own pathway. Because I know in a populous country like India, the many tests of these electric vehicles and big companies failed because it's a very populous country and there are a lot of people moving continuously. So
and it's a lot of people that's actually an aspect of research within the NRC. Like, when you're in California and you do the self-driving car demo on nice, clear, flat roads and everything's beautiful and straight and pretty, that's easy. But when you're in the middle of a blizzard and there are snowbanks that extend halfway into the road, like that is a completely new challenge. And how do you deal with person recognition in a snowstorm? How do you deal with not having any kind of lines to look at and you just have to figure out where you are based on other landmarks? Like that's all really interesting areas of research.
So I'll give you some interesting insight, and it will not sound pretty, but
Sure.
So okay, in India there's a where people are used to that way, and it's going to take a long time for autonomous vehicle to drive their self-drive, because you never know in the small roads when 3 lanes are following, people don't follow the lanes first of all, okay? And the guy from the 3rd lane can take U-turn, crossing the 2 lanes whenever he wants. And other people will stop and they will understand and they will not give them bad mouthing or stuff or not honk them, because they know it's usual practice and they're used to that.
Okay.
And it's getting better day by day. But how do you imagine that if the autonomous car is moving, somebody just suddenly goes away? So our people just keep moving, but the autonomous vehicle will just be shocked or either hit it or stop it for a while.
Well, I think that's okay. Maybe this is going to start branching off into too much of a tangent. So if it does, bring it back. But I think that's one of a really good demonstration of pre-learned bias. So whenever you're training any kind of machine learning model, you have to be aware that any bias inherent in the training data is going to be reflected in the output of the model. So in American roads, when a car veers off in front of you, the correct response is to stop. And that's because a lot of the training data came from there. But if your training data teaches the vehicle how to react to a bunch of different scenarios, and one of those scenarios is I'm in India and the guy 2 lanes over is doing a U-turn, what is the correct response? Well, that changes based on geography, based on the weather, based on the time of day, if people are in rush hour or not. Like, all that has to be taken into consideration, and I think it's a pitfall of a lot of demonstrations, like technology demonstrations, to show here's how well the system can work in the best case scenario. But you really have to get to the worst case scenario and show that it can, even if it's not perfect, it can still function better than a human in the worst case scenario before you get that widespread adoption. And that's on us as researchers to make sure that we are properly looking at all the data, that we are not just lost in our solve the technology problem, but also incorporate the human element and get feedback from the communities, the people who are going to be the end users, and or even if they're not the end users, interacting with the technology because they're pedestrians walking in front of vehicles. How, like, getting all that feedback, it's a challenge, but it's
I think instead of just reacting how the situation comes, obviously it took a lot of time to figure out that possibilities is everything in machine learning, how you have figured out the actions based upon those possibilities. But I think that's the best combo is what we figure out is that my eyes looking at that person. If he's signaling the side light from there or his hand is out, I am expecting that he will come here. So how much time you think that it will take for industries to figure out that way, that a machine is already predicting for a certain motion and then it will already prepare for itself. If that motion appears, they know what to do already. So how much time that will take, figuring out how the surrounding situations will happen, looking at the motions?
I mean, I can't say specific. Autonomous vehicles is a little bit outside my domain, so I'm not sure what the state of the art is. I remember hearing at some point that there was already functionality built into for vehicles to identify aggressive drivers. So, like, if you're in rush hour and you see the guy who cuts in front of another one, you kind of flag that car as, okay, I'm aware of that car and I'm going to keep track of him and make sure I'm not in his blind spot, and make sure that if I can get ahead of him and leave, then maybe I will, or just let him go ahead. I remember hearing at some point that was built into some autonomous vehicles, and I think so. I think it's probably closer than anyone realizes, and I'm sure the secret labs in Tesla and Ford and everyone have made a lot of progress there that we might not even be aware of, or might be in the vehicles that we're driving, but we're not explicitly aware of it.
Awesome. So let's talk about the cobots and copilots. So copilots are the regular ones. For example, in the Microsoft browser, there is a copilot nowadays given, so you can just complete half of the search and it will complete half of the things for you. Also, if you're analyzing some web development, there is a copilot. If you're doing some coding, there's a copilot. So your domain is mainly about cobots. Do you want to explain how it is so important right now and it's going to be even more important in the coming days?
Sure. So cobots is like a shortening of collaborative robots. And so they are, when I talk about cobots, usually what I'm referring to is going to be industrial arms, right? They look like robot arms, but they are designed to work more closely alongside people. They have a few features that make them safer to use. So an industrial robot might have pinch points that you could get an arm crushed between it. Cobots typically have very softish, like soft curves, smooth shells, and they have offset links, the solid parts between joints, that mean it's very difficult to get pinched between them. Obviously, if you give a cobot a knife, it's still not safe to necessarily work alongside a person, so it's still application dependent. But they also have like force sensors within their joints. So if they start moving and hit something, they can detect that and they can stop. And instead of just gonna keep going and crush you or whack you as hard as they can. So cobots are there to try and work alongside people, and I think that copilot analogy is a really good one, because one of the troubles I have, or one of the first impressions that a lot of people have of robots is that they're here to take your jobs and they're here to replace me. And I see it differently. I see cobots as a tool. They're something which can extend your capabilities and help you do your work. Just like a copilot is not there to replace your coding job, it's there to make it easier so that when you're trying to figure out what a function does or trying to figure out how to write something. It gives you suggestions, advice. Same thing with a cobot. If you're trying to do your work, the cobot is there to help out and do the things that a robot is better at, while you do the things that you are better at. So that could look like the cobot going and doing a lot of the like very precise pick and place. If there's a conveyor belt with a bin, it just grabs stuff off there and puts it in a precise location. But then when the time comes to grab that assembly and make some finicky little adjustment to an area that's hard to reach, that's the human can still do that. Or the human can be working on something and the cobot provides the tool, right? Your tool, the space in front of you as a workbench, that space is valuable. And if you need one slot for every different type of screwdriver that you could possibly use, because you have a highly flexible manufacturing line that requires a lot of different tool changing, that all that tool space can live behind the cobot. The cobot comes and grabs and presents you with the tool that you need based on the job, or the cobot knows that there are these different parts coming up. Here are all the fasteners you're going to need, and it's all laid out for you. That's really how I see cobots being leveraged as tools for workers rather than as complete replacements. Because we can talk a little bit more about that later, but I don't think that's feasible to just say, cobots are going to come here, we're going to replace everyone on the factory floor with them. And
that's what I was going to ask, because don't you think that cobots will be taking your data, and the companies who are developing the cobots, right, let's say, they will be noting the data just in future to make them completely a replacement for a human working. So let's say 5 people were working now, only one needs to work and just give directions.
I guess that is also dependent on the manufacturer. So like the cobot that we have down there, for example, like it's not hooked up to the internet. It's not hooked up to the internet right now. So the manufacturer's not getting any data that it might collect. And when it comes to replacing or reducing the workers, again, I think this concept of like just one-to-one replacement of robots or people with robots is a little bit hopefully misguided. I acknowledge that there are probably some companies out there that are maybe have that approach, that outlook, right? But myself as a researcher and from the other researcher that I've seen working on this, it's not there for that. It's to take away, robots are there to take away the dull, dirty, and dangerous jobs that it's not good for humans to be doing them. And people who are saying, man, I love breathing welding fumes while upside down, like that's the kind of thing that we want to take the human out of and let them do the work that they are good at and enjoy and is safe, and let the robot do things that are damaging.
Understandable, yeah. That's what the expectation is, but it can go out of hand very quickly. So let's see. What's your view about the electric vehicles? So currently there is a mandate pushed by the US current in power political party. Let's say Biden was trying, I have heard that he was trying to push the mandate that by 2035 the sales of the normal vehicles will stop or it will be banned completely. Mm-hmm. And then there is a debate it's still in discussion because of the debate that it will consume a lot of electricity. So what's your view upon that? How will we go forward with this electric vehicles? Is it better or it's going for the worse?
Yeah, not my area of expertise. So any opinions are entirely based on feeling and really not
personal opinion.
Yeah, personal opinion. We'll say. I mean, I think electric vehicles are great. I think they are a necessary step on the technology tree. I think there probably are still applications where you're just going to need gas, but you'd be very surprised by the breadth of vehicles that are being replaced with either like fully electric vehicles, or like alternative fuel sources like hydrogen
fuel cell,
where you are I know a lot of people have the concern of like, oh, batteries in cold weather in Canada, they'll never last. My vehicle will be useless in a year. Like there are tundra buggies that operate up in Churchill, and throughout the winter they have electric batteries powering them. They're electric tundra buggies, and it's really interesting to see how they tackle those challenges and how they are adapting to the climate. I think that with the interest of moving towards a sustainable economy and keeping an eye on our carbon footprint, I think electric vehicles are very promising, but of course not without their challenges for energy consumption, rare material sourcing, and all that. But as researchers, I think that what we're trying to do is find ways to address those problems and make it better for Canadians.
Yeah, I think for the future generations, if we are looking at a progressive approach, we should be okay to switch to EV rather quickly to save the environment first, and we can cross the that point of consumable electricity when we come to that point. And we would be start researching that once we have done the first step of switching from fuels to electricity, petroleum to electricity.
Right. And like if you have a fully electric vehicle, but you still get all the power from it by burning dinosaur bones, then you've just kind of traded one evil, or you've just moved the combustion away from you to maybe feel better about yourself. But there's not everything needs to change, right? But it's going to be slow. It's going to be a process. We're fortunate to live in Manitoba, where a lot of our energy is hydro and is relatively clean compared to a lot of other places in the world. So I think that where you can, if it makes sense, getting an electric vehicle or like a hybrid or plug-in hybrid vehicle is a good and responsible choice.
Okay, great. I think a lot about this with the robots coming into the future, and that's a mechanical part as well as a responsible part. That do you think there should be coming for all the self-driving autonomous robots, there should be a safety switch, or no?
Okay, so like if you're in a fully autonomous vehicle, should there be an e-stop that you can press and it will?
Yeah, there should be any, let's say, physical. Obviously, there will be the measures to stop it physically. There would be a switch somewhere, but should it be a remote safety switch that you can stop at a time if you think it's going risky or haywire? Because it's just a fascination. I don't know if in reality it has ever happened, but they show up in the movies or the novels have been written that they go out of control and they go and damage a lot of, they make a lot of harm to normal humans.
Yeah.
Do you think there will be a remote switch for that?
So and where I come from, it's the manufacturing environment. So it's robots that are typically grounded in place, like they're bolted to the floor. They have a limited reach, but even then, whenever you're controlling them, depends on the mode, but you have a switch. So if I'm programming the robot manually to say, like, I'm teaching it, okay, you have to go to this point, then this point, and that point, and that point. I use what's called a teach pendant to do that. It's like a tablet that's hardwired into the controller of the robot. And that has a 3-position switch. That 3-position switch is there because you have to hold it in the middle. So it's not like a toggle, it's not like a just flip toggle 1 or 0. It's resting state means the robot can't move. You have to pinch it just a little bit to keep it in that middle position so that the robot can be moved. And then if you either let go, the robot will stop, or if the robot starts coming towards you and you tense up and you get scared, that's the third position. That's like hard close, and it will stop in that scenario. And so it's kind of sore on the arm to hold that for a long time on end while you're programming, but it's a very robust safety switching mechanism. Once the robot's been programmed and you just want it to go and do its thing, you can put it into automatic mode. And you have to make sure that you've verified the tool path. You know that nothing's going to get hurt. You have to have safety interlocks, making sure that nothing's going to go into the cell when the robot's moving. And then you can run it automatically. So from my perspective, or given my background, I guess, it would be wild to imagine a robot without a safety switch. But I acknowledge that everyone has a different idea of robot, and everyone has a different idea of what level of control they need. I think that having built-in safety measures to any manufacturing robot is a fundamental like level zero necessity of building any sort of system. But I can only hope that people developing other kinds of robots are of the same opinion.
Awesome. So also we were talking about current transitions in the new world with the ChatGPT. So post the advent of the ChatGPT, have you seen a shift? You talked about how NRC is also developing their internal AI system, the Copilot system or COBOT system that will help you do the stuff, the generative models. It will help you guide the stuff, but also with the measures, making sure that that you don't leak a lot of data, and be careful about how you input the data. But when it came around, I think you were here when it came around. So what was the environment like? What was the culture? How was the shift? Was it a sudden? Was it a surprise, a shock? Because I am assuming that you already knew about those kind of things. For that department, who is the masters in those department already knew about this kind of stuff.
Yeah, the people working on that, working in machine learning, they I'm sure were aware of these developments. For us, it did happen suddenly. I think where all of a sudden everyone's asking, oh, what's this ChatGPT thing? But the NRC responded pretty quickly in saying, like, here's what you can and can't do. We're working on developing a safe space so that we can use it for research without compromising the integrity of the research. Obviously, if you start writing proprietary code and then you upload it to ChatGPT to ask, hey, can you fix the bug? Well, you no longer own that code. Sorry, OpenAI does, and they're probably going to take advantage of it, and you can't claim to own it. So understanding that's bad. But if you upload a publicly available scientific research paper and ask it to summarize the key points, right? That's not infringing on any of our data or putting our research at risk, apart from the usual caveats for using AI and making sure that you understand its outputs and trusting or not trusting, making sure you verify the sources and all that. So there was a bit of that sudden, oh, this is here now. But I've seen people, some people use it, some people don't. I think the biggest change I've seen is actually in students. So students prior to that, like it's nothing, right? It's not a concern. But then as soon as ChatGPT comes out, then the next generation of students are all in on it and asking, like, oh, can I use this? Or I use this for homework, or how can I, like, or even not assuming that it's okay, but just like this is any other tool like Word or Excel, like give me, like I want to be able to use it. I'm used to using it. Yeah. So it's been interesting to see that and to try and but I mean, I think it helps keep me abreast of what people or how people are using these new tools.
Let's talk about our country's standing point. We said we were top leader in AI, robotics, quantum technologies, and machine learning. So can you tell about Canada's advancements in this robotics compared to other countries, and also side by side also address how we are influenced by US, and what are our responsibilities in terms of sharing our research to any outside world. Can you
Sure.
shed some light on that?
So, I mean, I don't have, I don't have the secret knowledge that's going to say like, oh yeah, these are the areas that we're good at. In general, Canada has good, strong quantum research programs and like AI research. When it comes to robotics, I think we're strong in. I like to think we're strong in some of the research aspects, but we've, as a country, Canada has been lagging behind in terms of adoption. So the rate of adoption of robots for Canada is pretty low compared to a lot of other countries, despite the fact that we are ready to adopt. Like I read somewhere, so this is just unquoted source, but we're ready to automate. We have just in general a highly educated workforce with a lot of primary industries. We have the kinds of jobs that would, from any external observer, look like they're easy to automate, and we have the capabilities to do so, but we haven't. And so that's a challenge where we might have people doing really like leading edge robotics research without a lot of that supporting industry around us. And it's kind of, it's a question that I wrestle with sometimes in figuring out, like, is it a better approach to try and get people in at level 0, right? The 20 years ago robots, and automate their one process using 20-year-old technology, and then slowly walk them up the chain, developing that knowledge, that internal know-how, and being able to work your way up to where you want, like where you are with the research? Or do you advance the research enough, say these machine vision enabled cobots that can adapt their programming and are super easy to reprogram and easy to work alongside humans, to the point where it's just easy and any company is banging down your door to get them? Because, in the one instance where you're trying to walk people through the entire automation chain, you might just hit a roadblock, right? I think that's what's happened in Canada with our low volume, high mix. It's a big challenge, and you're just going to hit problems that you can't solve using traditional automation. Whereas if you want to spend time and money working on this advanced research without anyone explicitly interested in it, and just saying, we'll eventually be able to get to the point where we can introduce automation. It kind of requires a leap of faith to bridge that gap before people are fully invested and committed to that area of research. But I think we're on the right track, and we are getting better with robotics. And there are some companies, even local to Manitoba, that are doing very interesting robotics research that is I think going to be pretty fundamentally very significant in the way that we use robots going forward.
Awesome. So also regarding that, how was the ethics figured out at the facilities of NRCC? Because I will give you one example of the OpenAI.
Yeah.
What I've heard is that they have a red team and blue team, just A team and B team. They have the ready-made model to launch where ChatGPT can do everything for you. It's like a smart AGI, automated generative intelligence, which will do everything for you. They can go into your computer, write the code inside your computer, execute the software application, deploy it, and then come out of it. So they have it ready, but It's just too much for people to absorb at once. So that's why they're going slow, and also how much it's harmful. They have to look at that, being responsible. So that's why they are releasing slowly. They just released ChatGPT 4th version, which can keep memories across everything.
Right.
They know they are syncing the data across the world and keeping memory across all the chats, your chats, as well as across the person's data. So what do you think? Is that also common in industries and in NRCC to have teams recognize what are the ethical regulations you have figured out, but you can't launch that because of the risks?
And my research area is not in AI, so the
In robotics.
I can speak to robotics for AI. I don't know what other ethical measures are in place. For robotics, a lot of it is making sure that we adhere to safety standards, so that if we say that this cobot is safe to work alongside people, it actually is. But I can say that for the NRC, we have a lot of resources to tap into with regard to ethics. So we get a lot of talks and training on, here are some examples of unethical research. Here are things here are things to think about as you do research with. A lot of it's generalized because we're a very broad organization, so it's not specific to robotics, but it's for science in general. Here are some ethical questions. Would you experiment on twins? Do you use the Nazi data on twin experiments? Is it ethical? Well, you can't get it now, but you have the data. Should you use it? Questions like that to make you think about are you performing research in an ethical way, and resources to if we have ethical concerns and say that, if there's something that we think is going wrong, we have the resources to put our hands up, say this seems wrong, or let's stop and figure this out. But yeah, in terms of in terms of the AI side and limiting our research because we don't think the public is ready for that, I don't think, to my knowledge at least, that's not really the stance that a lot of what we have is taken. It's more like if we do research and it's for a company, we give it to the company. We don't just publish it to the world. So there might be something that is not ready for public consumption, but it's more so because a certain company paid for the research rather than because we think it's bad and going to ruin the world, and so we're not going to release it just yet.
Okay, so let's go forward to the final section of personal philosophy. So let me know what your personal opinions are there on this one, and this will be some staggering questions.
Sure.
So let's say, do you worry about seeing the future generations surrounded by robots as treated as equivalent citizens as humans or not?
I don't. I think, it'll take a lot of convincing for me to say that a robot is an equivalent citizen to a human. But I would say that when it comes to children growing up around robots or automation, that concerns me less than the existing real concerns of algorithms already run your life. Social media and your phone and everything is already tied to these these robots that are I think more influential on the real world and people and their psychology than a Terminator-esque walking body robot that touches things. Because when I say robot, everyone has a different thing that pops into their mind. But if your phone tells you which way to drive your car and you don't question it, you just click on the thing with a little green leaf beside it because Google says that's the best route. They've now decided where you're driving your 1,000-pound vehicle, and that, to me, that has more influence on the real world than something like a manufacturing robot that's just there to help you pick this object and move
maybe
it from
keep
one
you
place.
safe from going or into accidents.
Well, I think that's maybe this is starting to get off on a different tangent where, as an engineer, right, I am part of a professional association. I'm self-regulated. So other engineers make sure that other engineers are behaving ethically, are meeting the standards of what it means to be an engineer, and that we are always working to keep the public's trust. I know that there's been some contention about software developers or like software engineers. Are you allowed to call yourself an engineer if you're not part of that professional association? Do you have potentially more influence on public safety than someone who than a civil engineer who builds a bridge, right? Well, what about someone who builds an algorithm to determine, who gets what advertisements? Like that can have such a huge impact. I'm more concerned about the the people regulating themselves in that regard than I am about little Jimmy having a nanny bot that is always there to rock him back and forth and feed him in the middle of the night.
Yes. I think nowadays, especially our generation, I would say, is more or less their psychologies are controlled by social media rather than themselves controlling their own psychology or feelings, how they feel.
I think that, it's okay. I'll acknowledge the irony in getting this idea from someone that I saw online, but there's always that desire to not to have content or not be bored, right? Sitting in line at Tim's, everyone's on the phone or everyone is filling every moment, and I think it's still important to enable those quiet moments for self-reflection, for boredom, to have shower thoughts that are not tied to someone else informing your opinion, but it's just your own reflection and your own rumination that eventually leads to determining what your opinions are and what you value. It's important to have those times, I think.
Agreed. All right, so let's go to the next. This has been a constant debate in the world of software developers or AI lookouts, universal basic income.
Okay. Yeah.
So I'll just explain in a short that there is a fantasized or a real opinion that we see that a universal basic income is the future, is a possibility of a future if AI is replacing the jobs, because what I believe or many other people also believe that if it can replace medical surgery level equipments and potentially the doctors, I think it can replace every industry personnel and reduce the jobs from 100 to 1 ratio in a very long future, but it will also increase job in other sectors. So it's not exactly the right measure, I agree to that, but definitely there's some contention that jobs will reduce, and for those people who are not valuable to government in these schemes goes on universal basic income.
Right. I think that's a big question, and I have no background in the economics of that. So again, anything I say is entirely opinion and not based in
personal opinion,
economic
everything.
fact at all. I think that to me, when I hear that term, universal basic income, what I think of is that if you limit someone to that, it kind of depends on the scenario. So if we're in a world where AI has taken over everything and there is absolutely no value that humans can add, and nothing you do could be of any worth, and so everyone just needs to be supplied with this basic amount of income to sustain themselves. That's not a utopia. To me, that is a future to be avoided, and is kind of like the worst possible outcome for that for the far future. I think that there can probably be benefits to providing people with a stable, reliable source of income, regardless of who they are or what they're doing. I think that it's, COVID gave us the opportunity to kind of test that unintentionally for people who no longer had jobs and had to still be alive for a certain period of time while we adjusted to the current situation. Maybe that something like that will repeat if we hit a singularity and suddenly there's a factory run by an AI that's building robots and churning them out night after night. And we'll have to stop and evaluate and keep people alive while we figure out how to reposition them in light of this new technology. But I don't think it's an inherently good or bad idea. And I mean, so much can change based on the numbers and the parameters of the scenario. It's certainly an idea worth considering, but I hope that we're really far away from the point where all humans are out of work and we just have to, the AI government that runs us will just have to keep us alive with a pittance. I think that hopefully that's a much farther down the road problem, but supporting everyone to a basic level or a basic standard of living is a right now problem.
All right. Great. So let's go with the rapid fire questions, and then we will go with how to guide the future generations.
Sure.
So there are 3 to 4 rapid fire questions I have for you.
Okay.
Quickly answer just one of them. UBI or working individuals?
Probably working individuals.
Integration of biotech like Neuralink in humans, or purely therapeutic purposes of the chips?
I could see Neuralink being valuable. Yeah.
For the education systems, in-person learning or augmented reality mode of learning?
I don't think anything can replace personal tutelage, whether that be online or in person.
Okay. And this is, I know that it goes in hand to hand. Now the future question, next question, but practical research, according to you, what do you fathom more?
I like to think my research is practical, but I'm a researcher. I like to live my head in
like
the clouds.
Like a theory base or practical?
Oh, practical. Yes. Yeah.
And let's say for the cars, hydrogen fuel cell or EV?
I'll say EV.
Okay. Awesome. So let's guide the future generation.
Okay.
As yourself, you have made a good research officer out of yourself, I would say, graduating from master's and bachelor's and then you did master's in robotics. What are the tips you would give to the people who are fathoming the career in robotics?
So I guess the first point would be that there aren't a lot of programs for robotics. There are some at a few universities, but robotics is often the intersection of so many different domains, of mechanical engineering, of computer engineering, of electrical engineering, of software programming. It's of ethics and human nature. Like there's so many aspects to it that it's a blessing and a curse. It's hard to go and sign up for I'm going to be a roboticist program at a university, but it also means that anyone in any of these fields could potentially end up in robotics. So what that means is it's on you to do what to make that the career that you want. It's incumbent on you to learn outside of school the skills that you're not being taught. If you are in computer engineering, and you know that being a roboticist means at least trying to understand the mechanical aspects of how a robot moves, buy yourself a little kit, right? And build a robot yourself and program it and try to get it to move. Doing those things beyond just what limited courses might be available in university or college or wherever you're attending, wherever you're getting an education or wherever you're working, it's really on you to go outside and learn more.
Awesome. And can I give 3 tips to citizens who are pro or anti-robotic or AI invasion in life?
Sure. So I think that there's a lot of ignorance sounds like a bad word, but it's a lack of understanding of how systems work and what their purpose is that I think gives a lot of people fear. And I think there are a lot of ways to build that knowledge. Again, if you take it into your own hands and you are working towards that. So if you, like automation, just in general, same thing with robots. If I say automation, that can mean a lot of different things to a lot of different people. It's not inherently good or bad, and you can experiment with it and learn what it means for you. You can get apps on your phone where you're able to automate different processes. So if there's some annoying thing that you have to do all the time, that you wish your phone would just know, whenever I leave home, turn off my Wi-Fi and turn off my Bluetooth because I don't trust any public signals, that every time you leave the house, you have to remember to do that. Like there are ways to automate those functions. And if you learn and play with those, that I think can go a long way to breaking down the barriers to understanding what it means just to automate something. In addition, I think for people who have that fear of like robots are going to steal my job, that if you are genuinely concerned that you are going to be replaced by a 5'7", 165-pound humanoid robot with legs and it walks and it's got hands that feel, then consider that might be how your employer sees you. If that is a concern for you and you think that you could be replaced by that robot, then like I would be concerned to work for a company who they see me as that product, right? Interchangeable with that thing that they can buy. Or if you're a writer and you're working for someone who all they see you as is I'm going to feed you an idea and I expect a story to be output, and so you're worried about ChatGPT taking over your job, like that's a valid concern, and that's something that I think goes beyond just the technology is bad. Like maybe the person you're working for is bad. Consider that, because it's just like so many things. It's not I don't think it's the technology that's inherently good or evil. It's how it's used. And there have been accountants for thousands of years. Excel came along. Well, now there are still accountants, but they just use Excel as a tool. It can be the same thing with AI, with cobots. But for the people who are already on the other side, right, who are saying, this is going to be great, this is going to be awesome, it's incumbent on you to show that to people, to break down those barriers, to explain why robotics or automation or AI can be useful. You can buy your grandma a Roomba, right? Or if they can't, if they have a hard time vacuuming themselves, hey, look, there's this thing that you wouldn't expect grandma to be on the side of robots, but she has a Roomba. It's great. You could set up live translation at a church service so that newcomers can hear the message being said in real time, translated into their own language with the use of AI machine learning models that are taking like the speaker's voice and actually just pulling the sounds and rearrange them into a new language. Like that's incredibly powerful uses of technology that can be used for good. So it's up to you to show how they can be used for good.
I hope we are doing that.
I like to think so.
Yeah, me too. So thank you so much for giving your time. I think that's the end. And thank you so much for giving your wisdom, sharing the wisdom to us. I think that's a great, valuable lesson.
I appreciate the opportunity. Thank you very much.
Thank you. Hello guys, congratulations on finishing the entire video. So first of all, thanks for watching, and if you really liked it, hit the like button and share it to your friends. And if you want to keep listening to our wonderful podcast, hit the subscribe button below. Take care.